3.5 is a lesson on the properties of circles. Just like last unit, our last lesson of the unit was on circles and their characteristics and properties, and this unit as well. In order to verify them, we are going to be looking at the properties of circles again before getting into our review and our assignment and our communication questions, and then at the end of the week, our test. Yes, I can. So example one has to do with the right bisector of a chord. The right bisector of a chord. I'm going to go ahead and draw a circle. My apologies for it not being perfect. So there's the circle that we're working with. You can go ahead and draw a circle to the best of your ability. And we are given the points A and B on this circle. And again, we're just drawing it as close as we can. A is right here. It is the point 2, -4. And B is here. It is the point 4, 2. And a chord, we've defined before, but a chord is a line segment that joins 2 points on a circle. So A and B are 2 points on a circle, and the chord is the line segment that joins them. Last unit, we mentioned that the right bisector of a chord of any circle, any chord of any circle, will pass through the middle of the circle. Okay, so again, this picture is not perfect, but it's actually pretty close. I'm going to use a different color to draw our right bisector of this chord, which is going to pass right through the center of the circle. Okay, so again, for this to be a right bisector, it needs to cross AB at a right angle, and the line segment AB is going to be divided into 2 equal parts by this midpoint, M. Okay? So everyone should have about the same diagram as I have. This long one, this one. M, yeah, M. Okay, so here we have the right bisector of a chord, and what we need to do is verify that the center of the circle, verify that the center of this circle lies on the right bisector of the chord AB. Verify that the center of this circle lies on the right bisector of the chord AB. And in the drawing, we're also given that the center of the circle is at the origin, 0, 0. So we need to prove that the point 0, 0 is on the right bisector of this chord. Okay, a couple steps are happening here. What do we need to do to prove that O is on the line? What do we need to do to prove that O is indeed on this green line? Its coordinates are 0, 0. Let's work from the end. So we're gonna describe what we have to find, and then we're going to work backwards to actually find it. Is that the same way we've been doing with our problem solving? So what do we actually have to prove? What would prove that 0, 0 is on this line? Okay. Okay. So yes, we're gonna say all that stuff kind of backwards. So what does the question want us to find? It says verify that the center of the circle lies on the right bisector of the chord. So verify that 0, 0 is on this line. In order to do that, so please take these notes down. The point 0, 0 lies on the right bisector only if the coordinates 0, 0 satisfy the equation of the right bisector. Okay, so that's what we really have to find out. We need to know if the point 0, 0 is going to satisfy the equation of the right bisector. If it does satisfy the equation, then it's on it. If it doesn't, it's not on it. Okay, so now we know that we are going to need the equation of this line. What do we need in order to find the equation of that line? Okay, let's so what does that even mean? What do we need? So that's what we need to do. What do we need to get the equation of this line? We need its slope. Okay, so we need its slope. In order to develop, let's say, develop an equation for the right bisector, we need its slope, and what else? Can we find the equation of the line just with the slope? We need one other point on the line, right? We need one other point on the line. I can't use the point 0, 0 because I have to prove later on, once I get the equation, that 0, 0 is on the line, okay? So I'm not going to use the point 0, 0 to create my equation. I need to use this point, M, in order to create the equation. So in order to develop an equation for the right bisector, we need its slope and another point on the line. This point, sorry, not another, we need one point on the line. This point will be the midpoint M of AB. In order to develop an equation for the right bisector, we need its slope and one point on the line. This point will be the midpoint M of AB. So now you can think about that backwards and say, okay, first I need the midpoint of AB, then I'm going to use the midpoint of AB and the slope, which is the opposite reciprocal of the slope of AB. Once I have both of those things, I can generate an equation for the right bisector. Once I have an equation for the right bisector, I can sub in the point 0, 0 and see if it's true. So this is our method of problem solving. We first identify what we really need to find, then what do we need in order to do that, and what do we need in order to do that, and then we have a starting point. Now we know where to start. We need to start with the midpoint of AB and work on from there. Okay? Do you guys have these notes down? So yeah, when we do it, we're going to work backwards. So we have the midpoint, and we're also going to have the perpendicular line segment, the perpendicular slope of the chord AB. Yeah? Once we have a slope and a point, Melanie, then we can sub it into our point slope formula of a line. That will give us an equation. Then we sub in 0, 0. Okay, I'm clearing this. You have the steps written in order that we're going to do, except your steps are written backwards. And here we go. I'm going to clear this as well. So first we're finding M. M is xy. And we find the x coordinate by taking the average of our two endpoints. That's 4 plus 2 divided by 2. And the y coordinates is 2 plus negative 4 divided by 2. So the x coordinate, 4 plus 2 is 6, divided by 2 is 3. The y coordinate, 2 plus negative 4, that's negative 2 over 2 is negative 1. So we just found the midpoint right here. The midpoint, I'm going to rewrite my m out here so I can see it, is 3, negative 1. Okay, I also need the slope of my right bisector. In order to find the slope of my right bisector, I first need to find, I don't have enough information to find it. Okay, we're verifying that point O is there. We can't use point O until the end. We can't use it and assume it's true. We need to prove that it's true. So in order to do that, we need to find the answer a different way. We're going to get the slope of AB. So this is the next step. You can even put a big 1 by the first step there that we did. Put a big 2 by the next step that we're doing. The slope of AB is the change in y over the change in x. Well, the change in y over the change in x. It doesn't matter which point you start with, as long as you use that for both the rise and the run as the first point, okay? So here we go. We've got negative 4 minus 2. And in the change in x, we have 2 minus 4. Negative 4 minus 2 is negative 6. 2 take away 4 is negative 2. So this reduces negative 6 divided by negative 2 is positive 3. Okay, and negative divided by a negative is a positive. 6 divided by 2 is 3. If this is the slope of AB, therefore, the slope of my perpendicular bisector is going to be what? Negative because it's opposite, and 1 over 3 because it's a reciprocal. Negative 1 over 3. Great. So now I have the slope of our new line and y negative 1 over 3. Where? Up here? Yeah. Which negative 1? This negative 1 or this negative 1? So why is this negative? Because it's perpendicular to a positive slope. Remember, perpendicular is an opposite reciprocal. So if the slope of the original line is positive, its perpendicular slope must be negative. Any line that has a positive slope, if we're going to have a perpendicular line, it's going to be negative. Okay? If you have a negative slope to begin with, and you need perpendicular, it's going to be positive. Okay? So it's always the opposite reciprocal when we're finding a perpendicular slope. So I'm going to clear my board, but we have our important information here. We have the slope of our new line, and we have a point that's on our new line. So what formula are we going to use? Nice. We call it our point slope formula. Good. So point slope formula, y minus y1 equals m times x minus x1. Now we simply sub in the information that we have. We know that our point y on m is -1. So we have y minus -1. And we know our slope is -1/3. And then we have x minus 3. Look at that. They made it nice and easy for us. These guys are going to multiply nicely. Y minus -1 is the same as y plus 1. So I'll just reduce that to y plus 1 on the left. On the right, this is something you need to remember, guys. This -1/3 is going to get distributed, right? If I distribute something, I'm giving it to everybody. I'm distributing it. I'm sharing it around. This times -1/3 is going to go with the x. So it's going to be x times this number out front and -3 times the number out front. Okay? Please don't forget this step. So many of your answers to something like this end up looking like this. -1/3x minus 3. That is not correct. Okay? You have not distributed the fraction out in front to the -3. You need to multiply it by both terms inside the binomial. So here we go. We have -1/3x. And then we have -1/3 times -3. Okay? Which ends up being +3/3, which ends up being +1. Okay, so you should have this step. And now what do we need to do to get it in y equals mx plus b? We're going to subtract 1 from both sides, leaving just y on the left. Nothing changes to my slope and my x, but I'm minusing 1, so this guy basically just gets minus down to 0, right? +1 minus 1 is 0. Okay, well now I have an equation of the right bisector. What did we actually have to find out, though? We had to find out if the point O does lie on the new line. So what do I need to do? We want to find out if this point lies on this line, and this line has this equation. I need to see if the coordinates of the point satisfy the equation. So I sub in 0 on this side, 0 on this side. Anything times 0 is 0. So are these the same? Yes. The center of the circle satisfies the equation of the right bisector. Okay, we're writing a therefore statement. This is your last note, and this is an important note. Therefore, the center of the circle lies on the right bisector of the chord. And I left it very general because this is true of any chord in any circle. The center of the circle lies on the right bisector of the chord. So if you ever draw a chord and a right bisector, you can be certain that it will cross through the center of the circle, and we've shown you how to verify it in 3 steps. Homework for 3.5 is the worksheet that I've given you, numbers 1 through 8. So it's worksheet 3.5, numbers 1 through 8. Okay, tomorrow you can expect to get your assignment and your communication questions. You should also come with questions on the homework. The more homework you do, the faster you'll be able to do your assignment, and the more accurately, and the better you'll do on your test. And the better homework grade you'll get.